Good morning. We are team number 2, and we're going to present our problem situation, that is Airbnb rental price estimation. So first of all, I would like to give a general context of the problem situation, and for that I need that focus in Ruth. Ruth is a retired woman that has an apartment in Victoria, Canada, with 70 square meters and 2 bedrooms, 1 full bathroom, a kitchen, Wi-Fi, parking space, and a laundry room. So she wants to rent this apartment to generate an extra income. And yeah, it's important to say that this apartment has a prime location near Baker Park that is an attractive option from other travelers. So the goal of our project is to help to Ruth and to determine a price for her apartment using the data insights. So we meant to generate this price using important factors like property features, location, and amenities. And by using a linear regression model, we can estimate an optimal price to maximize the price of this apartment. And know what is better, if I rent the entire department or only one room. And just very quickly, I'm going to explain how was the organization of this team. There are 4 key stages. That was planning, research, the data cleaning, and the final regression. So with this information that I give us, we can start with the variables that we use in the project.
The variables that we eliminate were the variables with relation with the host, except the superhost, and variables with relation with the neighborhood after some filters, data of links or description and location from the places, dates and reviews and scores after some filters, and availability and nights of stay. We made some preliminary and superficial tests to availability and nights of stay to determine if they are or not significant to the price, and we make some regression to some of these variables to determine the same if they are or not significant to the price. And we kept the accommodates, the bedrooms of the places, bedrooms and beds. Some of these dates were null, so we used the mode to replace the null values to the mode value. The bedrooms we use, we change the letter values to number values, and the price that will be our independent variable.
The response variable. Yes. So after the cleaning and after some preliminary analysis to see which were the relevant ones, we fell in this like 4 constant. Well, how many people are accommodated, bedrooms, and beds. These are the inputs. And our very first regression model, it didn't have a particularly great R-squared value. So we checked some box plots to see if there were outliers, right? After removing most outliers, the value actually dropped. So we did several iterations to see how many outliers should be removed. After removing only the most extreme outliers, there was actually a great improvement in the R-squared value. And from then, we started doing by phases. We took a look at the highest residual values, and we took 5 of them out, right? So we made another iteration, and the value actually improved. Then another iteration, and once again we removed 5 values and calculated it again, and the value improved once. The value actually fell once, but in the next iteration it went up. After this, we wanted to see if it was possible to make it the R squared, the determination actually better. So we went back to the database and filtered only the hosts that weren't superhosts, since this describes the situation of Ruth. Since she is a new host, she wouldn't have that status, and it would be like better suited to the price that she would be setting, right? So after filtering, well, the initial R squared value for filtering is actually higher than the one after removing the highest residuals. So we did the process again. We removed 5 residuals and iterated it again, and with once more. This was done in 4 stages, and we arrived at this highest R squared value. So we removed, actually, we arrived at this highest R squared value, and we knew that we had to stop because removing more residuals actually resulted in falling. So we decided this was the way forward, actually. And now it was time to make 2 different models.
Well, for these 2 different models, we start to separating the full apartment and also the one room. First we do the regression for the full apartment. In this one, we obtain the R squared like 36%. We notice that we can do the regression correctly, but when we pass to the one room regression, it signals that it don't have a long term of values. So we decide to do a categorical predictor coding that this gives us our 2 regressions of our private room and our entire room. For this, I have to mention that first of all, we do our Pareto to see what variables are significant for this model. In this, we can saw that the accommodates are not significant for the model. So because of this, in our regressions, the variable accommodate isn't in the regression. And there is our estimation price for the entire apartment and for the private room. Finally, with our 2 prices, we can determine that Ruth will benefit of the 2 prices if, first of all, if she has another place to live, because it says that she lives there, and if she has another place to live, obviously it will beneficiary for her, that rent all the apartment, because he can get an extra money. But also of the taxes and all of that stuff, we also say that if she doesn't want to do a lot of things like the cleaning and all of that stuff, it can be beneficiary to only rent a room.
Right, and some things to note is, for example, our final regression actually doesn't have that giant of a R squared value, but we attribute this to the fact that actual Airbnb prices are more based on the images, on the descriptions, on the communication with the host. So it makes sense that these purely numerical values aren't enough to completely describe the situation. And actually some of the other regressions we did with some filters, like taking only the apartments with more star ratings, they have a higher R squared value, but it didn't feel honest, because it felt like cherry picking only some data to make it the best, when that isn't the point. We have to model the entire situation. So of course it's easier to only connect 2 points with a line, but if you're losing all the other points, it's not that useful, right? So this is what we believe is the best model for that situation, that takes into account everything. And also, another thing is that normality was a bit of a problem, because it couldn't be Johnson transformed, but that if we there just wasn't a transformation that was good with a 5% confidence or with a 10% confidence or even with a 15% confidence, there was a transformation that was good enough. And if we transform, it would be 10 seconds. We would have to do an inverse transformation to get back to the original units. And since that wasn't part of the topics seen, the inverse transformation, it would fall outside of the scope. So this is the best model we found. And that's it. Thank you very much.
Could you put, please, the prices?
Yes.
And how many iterations you did?
There were 4 iterations for no filter, and from that we did another iteration with the superhost filter on. Only non-superhosts were
How
done.
many? Sorry?
4 and 4.
I have 2 questions.
Yes.
If you use artificial intelligence,
No.
any step, are you sure?
No, yes. For the imputation, I knew that I had checked in another class the pandas library, so I just asked it to give me some documentation in order to get more, like to review the pandas library for Python.
Into
So-
Python.
Huh?
Into Python.
Yeah.
Yeah, into Python. I asked it to like give me that documentation so I could read it again and write again the code for the k-nearest neighbors method.
Okay, and the second question is, what else did you consider that your model is significant apart from Pareto chart? What else?
What else? Like,
Because you mentioned that you consider Pareto chart for identify if your model is significant or not. Is the only parameter or
no, we did the Pareto and the accommodation didn't actually figure in the critical value like this line, and that's one sign. But in the others, the other regressions, we had always noticed that the coefficient for the accommodates was actually very low and shifting kind of not as usual, not as predicted in the other coefficients. So that tipped us off. That made us like want to do the backwards elimination test, and it did confirm the fact that we should remove accommodates.
The value that we have in variables that is lower than 0.05. For example, with the accommodates, we have a value that is higher than 0.05, and for that reason, in the final regression, we don't consider the accommodates. So
Okay.
for that reason.
thank you.
Thank you.